Good afternoon and welcome to the Canadian Housing and Renewal Association webinar, Energy Efficiency and Affordable Housing by Enbridge. I'm Stéphanie Madeleine-Leduc, Manager of Policy and Research at CHRA, and I will be your host for today's webinar. Thank you all for joining us. Before we begin, I will give a brief overview of the webinar technology. I will then introduce our agenda and speakers for this afternoon's presentation. Today's webinar is in real time. You should now be able to see a title screen of today's presentation and be able to hear me via your computer speakers, headset, or through your telephone if you have chosen to dial in. You are currently all muted, and we do this to minimize background noise. However, if you wish to ask questions, which we encourage you to do, you may type your question in the dialog box on the webinar control panel at any time during the presentation, or we will address as many questions as possible at the end of the webinar during the Q&A. If at any point you are having problems with the technology, Mark Hughes here at the CHRA office is available to help. You can either send him a message through the Q&A dialog box on the webinar control panel, making sure you select him as the recipient, or give him a call at 613-594-3007, extension 22. Apologies, again, that's 613-594-3007 at extension 22. Moving on to the agenda for today, CHRA is pleased to have with us Cam Black, Energy Solutions Consultant, Affordable Housing at Enbridge Gas, and Ryan Schwartz, Lead Green Associate at the Weidt Group. This webinar will present on an innovative program in Ontario from Enbridge Gas Distribution that facilitates the comparison of hundreds of design options and their impact on energy efficiency and construction costs before you start a project. It helps project teams identify energy efficiency opportunities and incentives early in the design phase when they can have the most impact on energy savings. The program uses a web-based energy modeling tool to provide the building owner and design team with real-time feedback on energy efficiency opportunities. Using basic building information known from early design, energy models are automatically built. During this webinar, you will learn about this innovative program, including a case study of a completed social housing project. As well, you will learn about other affordable housing programs in Ontario that Enbridge Gas Distribution offers. Please note that Enbridge affordable housing programs are only available in Ontario. I now have the pleasure of introducing to you our presenters for today. Cam Black has been with Enbridge Gas since 2012. For the last 3 years, he has been assisting affordable housing providers identify and implement energy efficiency projects. In that time, he has helped them secure over $3 million in gas incentives and achieve annual estimated gas savings in excess of 10 million cubic meters. He brings over 10 years of experience in sustainability, energy efficiency, renewables, and business development. Also, we have Ryan Schwartz, a program manager and project manager with the Weidt Group, has 10 years of experience with energy analysis and measurement and verification for building performance. Since joining the firm in 2007, he has consulted with utilities and design teams on the design and implementation of energy conservation measures for commercial new construction programs. He currently manages the Otter Tail Power Commercial Design Assistance Program in Minnesota. Mr. Schwartz holds a Bachelor of Science in Mechanical Engineering from Iowa State University. He is an associate member of ASHRAE and an engineer in training. Welcome, Cam and Ryan. I will now turn it over to you.
Thanks, SM. Hi, everyone. Good afternoon, good morning, I guess, depending on which part of the country you're calling in from. My name is Cam Black, and as my title here says, I'm an Energy Solutions Consultant at Enbridge Gas. Basically, what that means is I go around working with affordable housing providers and help them identify energy efficient measures and financial incentives, and basically ways for them to save gas in their buildings. And reduce their operating costs. So that's sort of what I do. I spend a lot of my time in boiler rooms in the basement, looking at makeup air systems on rooftops. And today I'm just going to give a quick presentation on some of the programs that we offer here in our service area. So here's the agenda for the next hour or so. So I'm the first 2 bullet points. I'll just quickly cover who Enbridge Gas is, and get into some of our low-income programs and give sort of a high-level overview. At that point, I'll hand it over to Ryan, who will take over and contribute the bulk of the presentation today. So here we go. So Enbridge Gas is owned by Enbridge Inc., which is based out of Alberta, and Enbridge Inc. recently bought Union Gas. So Enbridge Gas and Union Gas are the two gas utilities here in Ontario. This slide here is an overview of Enbridge Inc. and Spectra, who previously owned Union Gas and is now owned by Enbridge Inc. So you can see the sort of the purpose for this slide is to show you that Enbridge is more than just a gas and oil company. We've got we own pipelines, we own renewable projects, wind and solar, geothermal, and we're across the continent as well. So we're one of the largest utilities in North America, servicing over 5 million customers. So narrowing into Ontario, Enbridge Inc. owns Enbridge Gas and Union Gas, who still both operate as independent utility providers. So all the programs you're going to learn about today are applicable to Enbridge Gas customers, and Enbridge Gas customers reside in the highlighted areas you see on the screen now. So we basically operate in 3 regions in Ontario: Greater Toronto Area and Simcoe, so they're combined into one central region. Out in the east of Ontario, we're in the Ottawa region, and then southern Ontario in the Niagara region as well. Most of the Weidt would be serviced by Union Gas. So I'm going to talk now about our affordable housing program. So we basically have 3 programs for affordable housing providers: residential, multi-residential, and new construction program. So the first 2, residential and multi-residential, are retrofit programs. So these are for existing buildings, and obviously the new construction is for new buildings. So first I'll cover residential. So our residential program is called the Home Winterproofing Program. So this is a free program, and there is a free program to any homeowner or housing provider who owns single-family homes. There are some eligibility requirements based on your annual income. You can see the chart on the table, or if you're participating in some government assistance programs, also identified on the slide there. So the Home Winterproofing Program is delivered by community-based organizations throughout our service area. So in each region, we have a dedicated delivery agent who runs this program for us. So the program includes a free pre- and post-home energy audit. So essentially that's a blower door test where they come in and do a pre-test and help you identify measures where you can improve the efficiency of your home. Typically it's going to be sort of envelope style measures, so attic insulation, wall, basement insulation, air sealing, and draft proofing. If your home is heated with radiators or hydronic convectors, there's also an opportunity for heat reflector panels, which help keep the heat in your building. And we can also include showerhead, kitchen, and bathroom aerators, so low flow devices to reduce the water consumption and ultimately the water heating. That's sort of our objective there. And as well as part of our safety program, we'd also include a free carbon monoxide detector per home and make sure that the existing monoxide detectors are working. So this is a free program. There's no cost to the homeowner or the housing provider. And again, it's aimed at, just like it says, home winterproofing, it's trying to like winterproof your home and make it warmer during those cold winter months and improve comfort for our low-income customers. So moving on to multi-residential. So again, this is multi-residential existing, so retrofit. So it's affordable housing, but we would also have a similar program for standard multi-res. So if you're not a social housing provider operating a housing building, but a private rental, we'd have a similar program. Essentially, the difference is the incentives are a little bit less, and there's no audit subsidy. So you can see here for affordable housing, the program offer at the top. So included in the program is a building assessment So that could be done by, that typically would be done by me. I'm not an energy auditor, but I could do a simple gas assessment, gas equipment assessment. We'd also provide an energy audit subsidy if you were to hire a consultant or an engineer to come out and do a sort of a ASHRAE level 2 or ASHRAE level 3 audit. We could provide incentive towards that. And then the bulk of the program is financial incentives to help offset the cost of high efficiency retrofits. So bulk of what we do is boilers. Like I mentioned at the start, I spend a lot of time in boiler rooms. So typically most of the projects we see are boiler retrofits because that's the bulk of the heating in affordable housing multi-res buildings. But any type of gas savings retrofit could be eligible. And the great thing about our programs is we'll actually develop a custom savings calculation and incentive quote for you prior to you moving ahead with your project. So it's a great way to sort of assess what your simple payback will be and compare it against, a different option. So maybe a more low efficiency option. If you're considering both options, you can sort of see what the cost is to move up to high efficiency and how Enbridge can help, make that decision a little bit easier. We also have some direct install measures as well. So basically when we say direct install, we mean no cost to the housing provider. I'll cover those on the next slide. And we can also do some resident engagement. So depending on what sort of work you're doing, we can help, let your tenants know what sort of work is being done and sort of how it can benefit them and how it can benefit the environment. We do spend a lot of time doing some resident engagement pieces with some of our customers. And the target customer, so really any building owner or property manager who's looking after a not-for-profit or social or assisted housing, cooperatives, shelters, and supportive housings are eligible. Within specific municipalities, we also have income-qualified buildings based on the census tract they're located in. So we've identified sort of low-income, heavy census tracts. So typically where the low-income incidence rate is greater than 40%, we've sort of designated those areas as eligible for our affordable housing program in an attempt to sort of reach low-income customers in our service area. So that sort of covers the multi-residential program. I'll do a quick brief mention of the 2 in-suite retrofit measures available, no cost. So we can do low-flow shower heads, provided that your existing shower heads are greater than 2.5 GPM, so that's gallons per minute. So they basically have to be low-efficient existing shower heads. And then, so you can see here on the right here, the low-flow shower heads. So those get installed by our contractor at no cost. And then we can also install heat reflector panels, like I had mentioned on the earlier slide there. So heat reflector panels, if your building is heated with hydronic convectors, or water-heated convectors, that's what I mean when I say hydronic, or radiators, so those are your classic steel radiators. These panels can actually fit in behind the radiators and the convectors, and they prevent heat loss through the exterior wall. And then by doing that, you can reduce the boiler supply temperature at your boiler and reduce your heating load. So we usually see about 10% savings on the space heating load of a building. And those can be installed at no cost to the housing provider as well. So that sort of covers our retrofit program, so the residential and the multi-residential retrofit. And then, so our new construction program was launched last year. And Ryan will talk a little bit more about this program, but I'll just give you a quick little high-level overview. So basically, the Affordable Housing New Construction Program is designed to help provide incentive to housing projects that are going to be offering affordable housing units to customers, and we can help offset the cost to implement some of these high efficiency measures. So we do that sort of through 3 phases: a technical assistance incentive and design incentive up front, where we'd actually run a design charrette for you. And also cover some of the costs you would incur to bring some of your engineers and consultants to the table. We'd also provide an implementation incentive, so once the work's completed, depending on which equipment you've chosen and which sort of efficiency level you're going to be achieving in your building, we can provide a up to $1,000 per unit incentive based on your ability to exceed Ontario Building Code. We have single-family homes are eligible, and multi-residential projects are eligible as well. The incentive structure is a little bit different, but generally it's sort of the same thing. Divided up into 3 stages of incentives. The final incentive being a commissioning incentive, so provided you get your equipment commissioned, we can also provide additional incentive to cover the cost of commissioning. The last thing we want is all this great equipment to be installed and then not set up properly. So that's what a commissioning piece would do. It would help ensure that your equipment's operating correctly and smoothly. So yeah, again, building eligibility. So for Part 9, it would be any single-family type of dwellings, and then for Part 3, it would be multi-residential buildings. So really, that covers everything I wanted to talk about. Again, if you had any questions, feel free to submit them through the bar on your right, and then I can answer them at the last after Ryan's concluded his portion. So now I'm going to hand it over to Ryan. There's our contact information for myself and Jen, who runs our home winterproofing program. So if you have any questions, you can feel free to reach out to us at any time. Now bear with me a minute while I pass this over to Ryan.
All right, thank you. Thank you, Cam. Again, this is Ryan Schwartz with the Weidt Group. I will pause one sec here while Cam passes the presentation over. Cam, are you able to just make me the or control the mouse? Would that work for you, and I can just click through it on your screen?
I think I made you presenter. Did you get a notice?
Yep. Do you want to just make me or give me control of your mouse, and then I can just click through it on your screen?
Yeah, I'm not sure how to do that. I thought I did that.
All right. Here, I will pull it up on my end here. So, SM or Mark, can you confirm that you can see the screen presenting on my end here?
Yep, we can confirm this.
All right, thank you. All right, well, thank you, SM and Cam. As Cam noted, we'll be diving into a little bit more in-depth study here of the Affordable Housing New Construction Program. But before I do that, I just want to give you a little bit of background on the Weidt Group and myself. So the Weidt Group here, we have over 40 years of experience with respect to energy modeling and consulting services. We currently have 8 offices throughout the United States, mostly on the East Coast and Midwest. And we have utility programs or provide services in 16 states in the U.S. In addition to that, we are also partnered with Enbridge here, working through the projects that we will present here shortly. In addition to energy modeling and consulting services, the Weidt Group also offers benchmarking services to help understand how buildings or groups of buildings are performing and addressing energy efficiency questions to try and help find best case scenarios or be able to identify where improvements should be made in a group of buildings. In addition to those services, the Weidt Group also provides custom software tools, several of which we will talk through here that we use in-house, but also provide those same software tools or various versions of them to other external clients. So as Cam noted, we'll be talking about the Affordable Housing New Construction Program here and dive into a couple case studies of projects that have gone through the program. Before we get into those actual projects, I wanted to start out by just kind of reiterating and readdressing the program eligibility components to the project. A couple of these Cam has already addressed, but just wanted to go over them one more time. So for a project to be eligible for the program, it must be a multi-residential new construction or major renovation or addition project. The major renovation projects needed to have the major systems in the building addressed. So whether that be mechanical, architectural, or lighting or electrical items, those must be addressed in those major renovation projects. In addition to those requirements, the project must also then 3 or more stories and greater than 600 square meters. All of the case studies that we will talk through here shortly were all new construction projects. In addition to that, the projects must also meet the eligibility criteria for public funding assistance for purpose of creating new affordable housing. In addition to those items, the whole essence of the project revolves around getting in early in the project design. So in order to be eligible, the project must also have been in the schematic design or early design development, as many of the strategies and items that are discussed through the program and process contribute to making or decision making. We want to get involved early before those major decisions are made, as a lot of times those early design decisions really impact the overall energy usage and energy savings potential of a project. And finally, the projects must be located in an Enbridge Gas Distribution franchise area. So the program did provide a number of services. As Cam mentioned, all of these services were complimentary, so at no cost to a building owner or a design team. The first of which was a customized energy model that simulated how the building or how that project would use and consume energy. From there, that model was used to identify and evaluate what strategies had the greatest energy savings potential. From there, we use those strategies to also evaluate energy cost savings as well as paybacks. For all of these strategies, since they are improvements or incremental benefit to a project, there are also associated incremental costs to implement them into the project. And to address that, we developed simple payback criteria to help teams identify what strategies might have the best potential and quickest potential via paybacks. In addition to that, financial incentives were also available to help offset the cost for implementing those energy conservation measures. As Cam noted, there was that implementation incentive to help address and alleviate those initial or additional upfront costs to the design team for plugging those measures into a project. In addition to that, there was also meetings and information transfer that the design team and owner had to provide and sit in on. And so, as Cam noted, there was that technical assistance incentive that is available to the teams to help account for that additional time and commitment to providing that information for the program. I want to take just one step back here and talk a little bit about whole building energy analysis. I won't go into too much detail here, but really this is kind of the building blocks of the program. Whole building energy analysis allows building owners and team members to identify what goals are important to them in helping make decisions. For different teams, their goals could be very different. One team could be completely interested in energy cost savings. Another team might be concerned with energy usage, and yet another team might be all in determining what they can do to get the maximum incentive through a utility program. So whole building energy analysis at least allows us a starting point for identifying what those goals are. And then in addition to that, it allows us to determine what energy conservation measures or strategies allow the greatest impact or are critical to meeting those energy goals and staying within a project's budget. Those two things combined allow for reduced time for teams exploring suboptimal strategies or those strategies or options that really don't meet the design criteria or energy goals, or those strategies that really don't get a lot of bang for the buck. And in addition to that, the program allows for early identification of mechanical systems, as mechanical systems are often a major component in space requirements throughout a building. And as far as mechanical systems go, that is really the key item we will talk about here shortly in our first case study. The whole building energy analysis coincides with the energy design assistance process. So this is the process that we followed through the Affordable Housing New Construction Program. The first step was to gather information. That was done via an application for the program where the team completed very basic information on the project. In addition to providing those project details, the team also provided early design drawings and narratives via the mechanical system, lighting system, anything that was available early on in the project. From there, we took that information and conducted a preliminary analysis where we built up a model, identified various energy conservation measures, and organized them into various bundles, which we'll talk about here in a little bit, and sat down with the team to identify which of those options was best. We then conducted a final analysis where, based on the information and feedback we received in the meeting, we fine-tuned the energy model to provide a truer or more aligned estimate of energy savings potential, and then an estimated incentive based on the design that the team was looking at. From there, the fourth step in the process was validation or verification. This process was completed after the project was complete and allowed us the opportunity to review final design documents, construction submittals, cut sheets, to verify that the various strategies the team said they were going to implement into a project were in fact present. From there, we created a final model and trued up the savings calculation to provide a final savings value to the team and Enbridge. From there, the various incentives were paid out for each of the projects. I believe that this chart on the screen here really captures the essence of whole building analysis and the design assistance process. On the horizontal axis, you can see costs. Those would be costs associated with implementing more efficient strategies into a project. On the vertical axis, you see savings. Those are going to be energy savings, cost savings. And through the curve here, you can see that as you move from a baseline or a code-compliant building, there are additional savings. And as the steeper the slope, the more increasing value there is for those strategies. However, once you get to a certain range, those savings start to diminish and do not become quite as cost-effective. So through the process, the goal is to determine which of those strategies really provide the biggest savings potential and meet the design team and owner's goals for the project. To accomplish that task, the program used NEO, or Net Energy Optimizer, which is an online modeling tool and interactive bundling tool that we have developed here at the Weidt Group. This tool allows us to take the very early information that project team is able to provide us and create a very detailed energy model to capture the savings potential of various strategies. It also gives us the opportunity to interact with a team and show them real-time what various combinations of strategies will do for them in terms of energy savings potential and impacts in incentives. So as opposed to a team having to choose a strategy, implement it into a project, have that project sit and realize what those savings are, we are able to quickly identify what those estimated savings are in a virtual model real time while sitting down with the owner and the design team. So now I'd like to dive into our first real-world example. The very first project that we did was located in southern Ontario in the Niagara region. This project was approximately 12,900 square feet, or about 1,200 square meters. It was a 3-story building. It was a senior living building, so there were 14 senior living apartments or units throughout the 3 stories, as well as some common area. That common area was the simple corridors or the lobby and communal space on the first floor, in addition to an office. So a very typical senior living building. The original mechanical design was to look at a gas-fired heating unit system for the apartments. For this project, the design team and owner were were concerned about the project budget. And so that was the main goal that we had identified early on in discussions with the team, and we worked to try and address that through our consulting and the program services. To start out, we gathered their application, their drawings, and their narrative, and we took that information and plugged it into the NEO tool. We built up the model based on the space types that were in the building and identified the critical items to develop our model. From there, we took the mechanical system and built in the same information, but this time on the mechanical side. For the NEO tool, the critical inputs are building up the geometry and the mechanical system. Major items that aren't known at the time in early design are assumed values. Those values are based on industry standards and typical values that one might see in these affordable housing new construction programs. So to make this tool work and function, we don't need to have every single input early on, because early on in the design process, those items are not known. But from there, we are able to determine a starting point for savings. This information was provided in our meeting to the team and allowed us to show them where their building is potentially using energy. From here, you can see that there is an orange dot. That orange dot was the baseline, or the starting point for savings. That orange dot was compliant with the Ontario Building Code. And from there, you can see that there's a bar chart below. That bar chart was their proposed system at code minimum values. So even prior to applying additional energy conservation measure strategies, this project was already showing some savings potential. In addition to showing some savings potential, we were also providing information to the team of where their building was likely going to be using energy on both a EUI, or a kBT per square foot, or a cost side at dollars per square foot. From this information, we were able to say that for this building, the heating load throughout the building was the highest energy user of the various end uses that we had modeled. But when it came to cost side, that heating component did go down. And that was just due to the difference in cost per BTU of heating energy versus electric energy, and the difference in gas and electric costs. But again, this is what we use to tell the team, or to help influence the team in assessing where they could potentially save money and energy through energy conservation, energy saving strategies. From there, we addressed various strategies. So we had a list of hundreds of strategies that we were able to fine-tune and select that were appropriate for this building. Our strategies cover everything from architectural items, wall, roof assemblies, to windows and glazing, mechanical items for the heating and cooling equipment, and lighting, as well as various plug load and service water heating or water heating needs. We fine-tune that list to the specific project because every project might be a little bit different, and we have the ability to analyze the strategies for their specific project. From there, we take their project's information and assemble some preliminary bundles. A bundle is essentially a virtual building, or a combination of strategies in a virtual sense. So we can outline for them the energy cost savings of their project at the end of the day compared to that code compliant building. This is, again, a starting point. As we conducted this exercise prior to meeting with the team, we had assembled the bundles in a good, better, best configuration. So again, if you were to remember that curve that we looked at, as you start to get higher, those potential paybacks do go up, because as you get more savings potential and more strategies, likely those items are going to cost more and you won't get as much of a return out of them. So we brought this information and presented it to the team. From there, we were able to have our interactive exercise with the team. We brought forward the mechanical, architectural, lighting, and plug load measures and discussed those three bundles that we had identified. From there, we were able to look to the owner and the team for input. As the whole, or one of the key important factors through this interactive exercise is getting that input from the owner and the design team. As that input allows us and them to realize which of these strategies help meet their goals of their project. And it also allows them to take ownership of the model, the process, and the tool. It's one thing to just present energy saving strategies, but if the team and in these meetings and charrettes, as Cam had noted, we can identify and in real time determine which of these might have great impacts or little impacts. That can all be done based on the input and all the thought leaders in the room at one time, which is very helpful to the process. And this is what allows us to eliminate those scenarios that might not be or have great savings potential or meet their goals. So for this project, we started out reviewing the mechanical system. And at this point, the team was pretty certain they were going with those gas-fired heating units in the apartment. So there wasn't much potential on the mechanical side for this project in terms of evaluating different options. As the team had noted that if they were to go this route, there was really just one particular piece of equipment they would use. So we were able to capture those savings of that equipment. As we move forward, our discussions turn to architectural measures. And again, based on those decisions that had been made early on, when it came to the wall system, there really wasn't much opportunity for savings here. But we were able to capture the level of efficiency that they were going with. When it came to the roof assembly, this team did have some potential. So as you can see from the three bundles here, in bundle 3, we were able to shift that R value out to show them if you did go with a R value of R60 compared to the R50, this would be your additional savings potential. And from there, we were able to capture what the impacts would be in incentive as well. On the architectural side, we were also able to address the glazing strategies that that team was looking for. They were able to provide us with the several different options they were looking at so that we could update and customize Bundle 3 to show them the impacts there as well. We also address lighting through this project, and this is one of those items that in a design process, the lighting is likely not known definitively at the time of these discussions. As I noted earlier, we want to try and get involved in a project early in schematic design or design development. And at that time, lighting layouts, fixture selections, they're really not known. So what we try and do through this process is to just capture the installed energy or input wattage of a project. And as you can see here, we organize our strategies in a stair-step pattern. As through discussions with the team, they had not yet made those selections. So we wanted to try and show them how if they went with the more efficient scenarios or installed fewer lights to still meet their design requirements or foot candle levels, they could potentially save energy. And what we're showing on the screen here is the apartment lighting. And so we had built that up to show them their various options there. In addition to the apartment, we also presented to them how the various measures in the common areas as well as their little office would factor into those calculations as well. In addition to lighting design, lighting controls were also addressed. This was a smaller project, so the lighting controls and daylighting controls had smaller impacts, but as we learned in some of our future or our later projects, there were more savings potential tied to those various measures once the projects became larger and some of these supporting spaces outside of the apartments increased in size. From there, the final section that we had addressed with the team was various plug load strategies and service water heating strategies. For plug load items, we really looked at did a project have refrigerators, clothes washers, or some projects might have dishwashers. By going with more efficient equipment there are significant savings tied to those items. In addition to that, there are service water heating strategies that could be applied. And as you can see from this chart, the team here was pretty committed to going with high efficiency condensing service water heaters. So we had applied those across the board. When it came to low flow or water sense shower heads, the team was uncertain if they would implement those. So those were located in our bundles 2 and 3 just to see what the overall impact was for those strategies. At the end of the day, this is kind of what accounts for that preliminary analysis that we talked through in our design assistance process steps. After this meeting, the design team noted that there may be a potential design change for their project. As we noted earlier, their initial design was gas-fired heating units for the apartments. But we also noted that the project budget was also of importance. And as the team began to evaluate costs that came in for the project, they determined they may need to switch mechanical systems to go to a lower upfront cost system. That system was our scenario 2, or our electric heating units. So this was a perfect scenario or a perfect case study to come up for the program, as with Neil and with the program, we were easily able to identify this and model this for the team and show them what impacts their original design or their gas-fired heating system would have compared to that of the lower upfront cost electric system. So we provided the team with some revised results after gathering that information. Again, this chart is very similar to the initial one that you saw, providing the energy use, kV2 per square foot breakdown, as well as the cost breakdown. The HVAC1 was the gas-fired option, and HVAC2, as noted on the chart, was our electric heating option. You can see here that right off the bat, a code minimum building, the electric option showed a lower energy use intensity due to the efficiencies of that system compared to that of a gas-fired system. However, when looking at the energy use in terms of cost, you can see that the HVAC1 has significantly lower energy costs tied to it, again, due to the difference in gas versus electric energy cost per BTU. But in addition to that, we also provided them the same breakdown showing them what the energy or the end use values would be for each of their scenarios and how that contributed to the overall starting point for savings potential. From there, again, we had 3 bundles in each scenario. Other than the mechanical system change from the gas-fired unit in the apartment to the electric heating option for the apartment, all the other strategy selections were in fact the same. All of the architectural items, lighting measures, plug loads, service water heating were consistent between the 2 scenarios and the respective bundles. In the chart here, the respective bundles that had the same architectural, plug load, lighting, and service water heating strategies would be referenced by Bundle 1 and Bundle 4 in the red and the blue. Referencing those 2 bundles, you can see that the heating scenario had an increase in savings potential in terms of energy costs. That was because the electric option, or Bundle 4 in blue, was the highest energy cost of all the bundles modeled, and Bundle 1 had a relative savings of over $5,000 compared to its electric counterpart. That same trend was seen throughout the other bundles as well, so referencing Bundle 2 and 5 and 3 and 6. So based on this, we were able to determine that the gas heating option had an increased savings potential on an annual basis for energy costs. When we paired that with an additional breakdown and analysis of the additional costs to go with that gas-fired unit, we determined, or the team was able to determine, that that additional cost for this project was just under $12,000. But in addition to that, the increase in savings potential going with the gas-fired option led to an additional incentive of $2,100. When doing a simple payback analysis of that additional cost, the incentive, and then the additional relative savings of the gas unit compared to that of the electric unit, the payback in years was just under 2 years. And for the team, that was a very good payback. And so the team ended up going back to their original design and going with the gas-fired units for the apartments. And they ended up selecting Bundle 1 at the end of the day. That Bundle 1 contributed to an estimated savings in terms of energy of 36%. That put their estimated incentive at that max incentive tier of $1,000 per unit that Cam mentioned, and since it was 14 units, it was a $14,000 estimated incentive. And you can see from that, that estimated incentive easily covered the additional cost of the gas-fired unit over the electric unit and led to good savings potential. However, this just was the first part, or the design phase. Once we had that information, we were able to identify where the various savings of that project were located. From the pie chart you can see on the screen here, you can see that there was an increased heating and cooling efficiency. That contributed to the most savings potential of the selected strategies. The improved lighting design and controls contributed to about 16% of the overall cost savings of the project. And then the reduced plug loads. That was modeled as Energy Star equipment and factored to about 11%. All of the other items contributed to about 17% of the cost savings and were strategies that helped reduce service water heating, cooling, heating set points, and then improvements to the envelope. But as we noted earlier too, the final step in the process was our verification or validation phase. Once this project was complete, we were able to review their final construction documents, construction submittals, and project cut sheets. When we reviewed that information, we determined that they had implemented 96% of the original modeled savings. And so from there, we were able to update our model and determine what their new savings and incentive would in fact be. When we adjusted the model based on what we found in the project, we determined that now the savings potential was approximately 35% energy savings over the Ontario Building Code. So it went down just slightly, but we were able to, with that, calculate that incentive. And the 35% savings threshold was still in that max incentive tier, so the project still realized the $14,000 incentive. A few key items to point out here were that the 96% of the original modeled savings was due to some strategies coming in at higher efficiency levels and some that were not implemented into the project. And so that trade-off of more efficient here, less efficient there, is captured in the verification or validation phase. And for this project, they did not implement Energy Star equipment, but we did realize that they had much higher energy savings on the lighting side. So as I noted earlier, the lighting design was not known at the time of the original meetings. And so our estimates we provided to them were just that, estimates. But when the project was complete, we were able to do takeoffs and verify their actual design, and it came in much lower than those original estimates. And that's what helped this project achieve its savings and incentive goals. Now I'll just capture a few other case study projects that are in process. The next project we looked at was a 42-unit, 4-story building at just over 4,100 square meters. This project was in the Ottawa region. This project was, like you can see there, larger than our first project, and also had some commercial space on the ground floor that we had included in the model. This team had identified measures that were contributing to savings and was really driven on significant envelope improvements. So that was one of the main areas of focus with this project, identifying and modeling what their R values and wall, roof assemblies, and glazing assemblies were to meet their goals for this project. This team also had multiple scenarios that they wanted to look at. This team wanted to identify again how potentially different reheat options throughout their building would contribute to energy savings, use, consumption, and savings. And so there again, we were able to model for them an electric reheat option as well as a hot water reheat option, which would have added boilers into the project. This project has not yet reached the verification phase, but based on the early estimates that we've made, this project was estimated to save 30% energy savings and thus meet that maximum incentive rate through the Enbridge Affordable Housing New Construction Program. As we move forward here, the next project was yet even larger at 158 units, 12 stories, and just over 19,000 square meters. This project was in the Toronto area and did not have a large retail or commercial space, but did have a significant parking garage underneath the project. This one was also a little different in the fact that it had a district mechanical system. That district mechanical system was modeled and addressed to account for the high efficiency levels associated with that district system. The other area that was of key focus here was due to that parking garage, we were able to identify various control strategies to address the ventilation loads and requirements for those spaces. At the end of the day, this project is estimated to be at 20% savings potential, and again, has not yet been completed, so just in the design phase at this time. The next project was a similar size to the one we just talked about. It had 162 units and was a 7-story building at just under 19,000 square meters. This was in the region of York. Again, like the previous building, had a large parking garage, but did not have a district system. This project had a high-efficiency hot water and chilled water system serving the heating and cooling loads in the building. This team also strived to make major improvements to their lighting design and lighting control systems. When we had looked at this project, there was also a small retail space where we were able to make adjustments based on updates in that preliminary meeting. When they had previously provided information to us, that retail space had fan coil units, but then in the meeting, they had provided us some new details or new estimates that noted that that space would now have air source heat pumps. So after that meeting, we were able to make that adjustment in the model and provide them with the updates in energy savings potential and incentives in meeting minutes shortly after that meeting, so that they had updated and new information to finalize their design decisions. When we had modeled that one was estimated to be about 25% energy savings tied to that project. The final project that we had looked at was, again, a little smaller than the previous ones, but was a 67-unit project of 4 stories and just under 14,000 square meters. This project was also in the Toronto area, and like the previous one, had a high-efficiency hot water and chilled water system. Also, like the previous project, these folks and team and owner were also very interested in lighting design and the improvements and what those strategies could offer them in terms of energy savings. Throughout this project and during and after our meeting, we were able to identify a few items that needed to be updated. And again, as I mentioned, with this program, those changes can easily be made and new incentives and savings estimates can be provided in a very short time frame. For this project, the area or building scope and size changed slightly from the original documents that were provided. So once we got those estimates updated, again, we updated the model and were able to provide this owner and team with updates in strategies, savings, and incentives just following that meeting in a very quick time frame. And again, they were able to use that information to help influence some of their design and lead them to about 32% estimated savings. And again, that max incentive rate for their project. That is really all I have to capture here today. I guess at this point, I can turn it back over to SM if you want to highlight any questions or comments that have come in as Cam and I have been presenting.
Hi there, so this is Stephanie Madeline with the CHRA, and we can now open the floor to any comments or questions. So you can type them in the dialog box on your control panel if you haven't already. So one question that we do have, and this is both to Cam and Ryan, is that while your programs are currently only available in Ontario, to your knowledge, do similar programs exist or are they offered in other jurisdictions?
Yeah, I can field that one. So yes, provinces would have, or not provinces, utility providers in each province would have similar programs. So I just did a cursory look earlier this week. So I know FortisBC is British Columbia. In Alberta, there's Alberta or Efficiency, I believe it's called. Moving east, Saskatchewan has got Sask Energy and Sask Power are the two gas and electricity providers there. I believe it's Manitoba Hydro in Manitoba. Quebec has Gaz Metro, which is the gas provider, and Hydro-Quebec. And then in the Maritimes, New Brunswick Power, NB Power, is the utility provider there, and they have incentive programs and rebates. And then for PEI, it's called Efficiency PEI, and Nova Scotia Efficiency is a provider in Nova Scotia. Newfoundland and the territories, your best bet would be to refer to Natural Resources Canada, and I know they have a website there that you sort of can choose your province by their map, and they'll direct you to all their financial incentives for energy efficiency.
Thanks so much for that answer. I believe that is all for today, and many thanks from all of us at the CHRA to Cam and Ryan for your time in speaking with us today, and thank you to our audience for participating. The CHRA's next webinar will be taking place on the 21st of November 2017, when we'll be joined by Metro Nonprofit Housing Association and Camponi Housing Corporation to talk about tenant engagement and supportive services. Check out the CHR website at www.chra-achru.ca/programs for more information. Today's presentation will also be made available on our website in the next few days, so check back soon. Thank you, and bye for now.